Hello, welcome to the presentation of Dr. Loose GmbH, your competent partner for welding consulting, welding simulation and manufacturing simulation. Dr. Tobias Loose is the founder, president and shareholder. He is international welding engineer and expert for welding and heat treatment simulation. Developer of welding simulation software FabWeld, in charge with research and development of methods to improve the efficiency of industrial applied welding simulation, development of methods to accelerate the welding simulation for large structures, the integration of welding simulation in the process chain simulation, public relation to promote the application of welding simulation, and finally the integration of welding simulation in the product development process. Advanced fabrication engineering for welded structures. FabWeld. FabWeld is designed to set up advanced simulation models for the fabrication analysis of welded structures. FabWeld supports all fusion welding processes, brazing, and heat treatment. FabWeld provides to model the assembly, the multi-stage assembly, clamping, unclamping, and mechanical loading. Your benefits from FabWeld: high precision, simulation, and result quality. Ensure and optimize your welding and fabrication design in advance. Get the first time right. Save costs, resources, and try-out loops before your fabrication starts. Our service: welding simulation, heat treatment simulation, heat engineering, and assembly simulation. With the distortion analysis, we calculate the deformation coming from the welding process and also coming from the clamping and unclamping situation. We analyze the complete distortion for welded structures. Our simulation method is validated. Have a look on this validation experiment. 18 tack welds, 2 supports removed after tack welding, 2 multipass welds with 3 passes, and 17 single pass fillet welds on an orthotropic plate with 5 stiffeners. See the physical experiment on the left-hand side and the virtual experiment on the right-hand side. For the welding simulation, the deformation are magnified 5 times. The experiment was performed in collaboration with Time Technology Institute for Metal and Engineering and Golduck Technology Incorporation in Ottawa, Canada. Have a look at the excellent validation results. The vertical distortion over time is plotted at 5 points where the cable wire sensors are placed in the physical experiment. At same location, the vertical distortion is evaluated from the simulation. Red is a physical experiment, blue the virtual experiment, the simulation. See the very close accordance between experiment and calculation, and this accordance is achieved throughout the process. This means we can precisely predict the deformation that comes from the welding during the whole process and use this information for the analysis and understand the welding process and further to improve our process. Our distortion management requires more than only a welding structure simulation. We simulate the complete assembly of welded structures in multiple stages. We take into account the clamp kinematics. We take into account the imperfect sub-assemblies. We take into account imperfect single parts, and we simulate stage for stage. FabWeld is designed for assembly analysis. On this video, you see the deformation coming from the clamp closing calculated with FabWeld. We secure the assembly process. We analyze insertion issues, as you see on the left-hand side, which come from deformation during the welding process. We make a gap analysis to detect gaps coming from the welding process, and if the gaps are critical, we improve the clap or the tack design to provide a stable process. We ensure the distortion behavior. The analysis of the distortion evolution, the reduction of the deformation, checking the tolerance, and perform a sensitivity analysis. You see a battery tray. On the left hand side, the first design of manufacturing. On the right hand side, the improved design with reduced deformation. We have two main tasks for the distortion management. The first task is the straightforward simulation of the manufacturing process, which is a proof of the manufacturing concept. The results are verified or non-verified. In case of non-verified, optimization loops are required. The second task is the sensitivities on tolerances, which is the sensitivity of the welding process, which is the sensitivity from the clamp device, or the sensitivity from imperfect single parts or imperfect geometry. So the results are small, moderate or high impact on distortions. In case of unacceptable distortions, resolve the high impact issues. We also provide residual stresses analysis, microstructure analysis and weld quality analysis. See some examples on this slide. On the left column we have a multipass T-joint. The picture on the top shows the temperature field during the last pass. In the middle we see the result for tempered martensite, and on the bottom the residual stresses according for Mises is plotted. In the middle we have a laser welded specimen made from boron steel, press hardened. On the top we have the calculated hardness, in the middle the tempered martensite proportion, and on the bottom side the longitudinal residual stresses. Our vision is to determine the weld strength by welding simulation. This is part of our recent research and development project. We want to replace the physical tensile test by numerical tensile test, as you see on the animation on the right hand side. Let me close this presentation with a look on our partners. Thank you very much for your attention.